Hello. In this video, I'm going to teach you how to find the mean, or we said that the expectation, okay, for a continuous random variable. Okay, I repeat again. For this video, I'm going to teach you how to find the expected value or the expectation or the mean of x, which is a continuous random variable with the given probability density function. So for finding a mean, so we are using probability density function. All right. So it's there's only way. If you want to find the mean, you have to use the probability density function. So okay, this is the density function for the continuous random variable. So to find the mean, okay, mean will be right at expected value for random variable, right? It's an expected value for random variable. Sometimes we just write it as a mean, right? So to finding this mean, so you just I'm not going to introduce all the formula, right? But you just see how I'm going to find the mean by using the probability density function. Very simple. Okay, you just integrate everything. Okay, from 0 to 1, 0 to 1, x over 3 dx. All right, x over 3 dx. So plus with integrate from 1 to 3. Okay, 1 to 3, which is 1 over 3 dx, and right. So 1 over 3 dx, followed by 3 to 4. Okay, 3 to 4. 1 over 3, 4 minus x dx. All right. So but this is, when you want to verify that this is a probability density function, you have to adding up all the interval, integrate all the interval, find the integral of all the interval, the value, and later add them up, you're getting 1, right? So if you're finding a mean, it's just like you adding up everything here, okay? 0 to 1, x over 3, 1 to 3 for this interval, 1 over 3, and 3 to 4, 1 over 3, 4 minus x for this interval, right? So, but because you are finding mean, so you have to multiply a x here. If you look at the expected the value of the random variable here, right? So you have to multiply a x. You have to multiply a x into the integral, all right? So means that you multiply with x into the integral. So if there is an x square here, then you multiply a x square here. All right. So now we talk about mean, right? We talk about mean. So how to find mean? Very simple. Just like you adding all the integral, but you just multiply it with x for each of the integral, all right? Because there's x here. So now then you integrate from 0 up to 1. So x to the power of 2 over 3 dx, plus with 1 up to 3 x over 3, plus with integral from 3 to 4. So you multiply the x, so you can take out the 1 over 3, okay, if you want. So this is a constant, right? So you multiply the x, then you have 4x minus with x to the power of 2 dx. So if you calculate, evaluate all this integral, you are getting your mean. Very simple, all right? So this is what I do, okay? This is what I do. So later on, integrating this, you have x cubed, right? X cubed over with 9, right? X plus 2 plus 1, you have cube, over with 3 times 3, you have 9. So 1 over 9, I take out from the bracket. So it's from 0 up to 1. And for this also 1 over 3, x, if you integrate x over 3, okay, if you integrate x over 3, you are getting x power of 2, right? Over with 3 times 2, 6. So x squared over 6. So I taken out the 1 over 6, and we have x to the power of 2 from 1 up to 3. So, and for this 1 over 3, integrate 4x, we have 4x 1 become 2 over 2. So you're getting 2x to the power of 2 minus with x cubed over 3 from 3 up to 4. So you just have to be patient to evaluate all this. Okay, 1 over 9, 1 cubed minus with 0, plus with 1 over 6. 3 power of 2, you have 9 minus with 1, plus with 1 over 3. All right, simple integration, right? Evaluation. So you're putting 2, 16, right? 16, 2 times 16, 32, minus with 64 over 3 minus with, you're putting the 3, 9, 2, 9, 18, right? 18 minus with 3 power of 3. 3 power of 3 is 27. So you're getting 9 here, right? So if you evaluate all this, you are getting your mean. Okay, let's calculate. Right, I will get the value of mean after I calculate all this. I will getting the value of 2. Alright, the value of 2. So the most important thing is this. Alright, you have to know what to do. Alright, very simple. So if there is an x here, you just multiply your integral everything with x. If there is an x square here, you multiply your integral everything with x squared. Alright, so okay, let's move on by finding the value of ex squared, expected value for x power of 2. Alright, now I'm going to find the expected value of the function x squared. Right, so okay, I'm going to show you it's the same thing that you want to find this. So you're just doing this, okay? You're just doing this. Usually you will integrate from 0 to 1 for x over 3, alright? For x over 3 dx. Plus with 1 to 3, right? 1 to 3 for 1 over 3 dx, followed by 3 to 4, right? 3 to 4 for this function, 1 over 3, 4 minus x dx, right? Usually we're doing this, but you know that if you integrate, if you evaluate the integral one by one and adding up everything, you are getting 1, right? This is a probability density function. So if you're adding up all the interval, the total probability will be 1. But now you are finding the expected value of the function x power of 2. So with the expectation here, you want to find x power of 2. So you have to multiply all the integral with x power of 2, right? With x power of 2. This one also you multiply with x power of 2. And this one also you multiply with x power of 2. This is very important, alright? So if the question requires you to find the expected value of x power of 3, you just multiply everything with x power of 3. If the question asking you to 1 minus x, expected value of 1, you just multiply everything with 1 minus x. The bracket means that the bracket will change, become 1 minus x. Alright? Expectation of means in general, expectation of a function gx, right? Let's say gx, the function. So you have to multiply the function, all the integral with gx, gx, and gx. Alright, so that is what you must know. Alright, so now how to evaluate this, right? Evaluate the x squared. Okay, go slowly because this is integration, so you have to be very careful when you're doing. So x squared, right? Your x cubed over with 3 dx. Plus with 1 to 3, right? X squared over 3 dx. Okay, so 3 to 4, you can take out the 1 over 3, right? This constant 1 over 3 you can bring out from the integral. So then you multiply the x squared inside, so you have 4x squared, right? 4x squared minus with x cubed dx. Now you have to be patient in evaluate all this simple integration. Okay, so for this you are getting x to the power of 4, right? You're adding by 1, 3 plus 1, you're adding by 1, so you're getting x power 4, right? X power 4, and divided by 4, 4 times 3, 12, so 1 over 12. So you have to evaluate from 0 to 1. Okay, for this you have x power of 3, right? Plus 1, you have x power of 3. So x power of 3 divided by 3 times 3. So you have 9. So 1 over 9 from 1 up to 3. So for this, 1 over 3, integrating this, you have 4x power of 3 divided by 3 minus with x power of 4 over 4 from 3 up to 4. Okay. Then by evaluating all this, you were getting the value of ex squared. So substitute 1 over 12, 1 power 4 minus with 0, plus with 1 over 9, 3, substitute 3 power 3, you were getting 27, right? Minus with 1 power 3, you're getting 1, plus with 1 over 3, alright? So 4 4 times 4 power of 3 divided by 3 minus by 4 power of 4 divided by 4 minus, substitute this 3, so become 3 cubed divided by 3 minus with 3 power of 4 over 4. Alright, and then the value that you get will be the value for expectation of x power of 2. So you are getting the value of 29 over 6, right? 29 over 6. So means I have already evaluated the mean, and I have what? Ex, expectation of the x power of 2 will be 29 over 6. Alright, so later on the question will asking us to find the variance, right? Asking us to find the variance. So how to find the variance? Alright, to finding the variance, right? The formula for variance and the property of expectations and variance are all the same between discrete random variable and continuous random. I repeat again, the formula for variance, is derived to be ex squared minus away the expectation of x squared, right? This is sometimes we're using the mean, right? So the formula for this formula is the same for when you're using to evaluate the variance for discrete random variable and also continuous random variable. It will be the same, right? So how to evaluate the variance for this distribution, right? So variance of x, we have already know the value of ex squared here, right? Is 29 over 6. Just minus with the mean square. Then you are getting the variance for this continuous random variable. So which will be 5 over 6, right? The value here will be 5 over 6. This is the value of variance, right? And I also want to tell you that the formula for the properties of expectation, for example, expectation of a constant, we're still getting a constant. Okay? Expectation for a constant multiplied with the random variable is the same as ax, right? So the expectation of ax plus b is the same as ex, right? Aex plus with expectation of constant, b is another constant, right? You follow this, you are getting the constant, right? So you have to remember all this. Please jot it down, right? Please jot it down. So through this video, everything I will include it, all right? So if I said variance of a, variance of a constant, you are getting 0, right? And variance of a constant multiplied with x, it will be a to the power of 2 variance of x. So if I have variance of ax plus b, so you will have a to the power of 2 variance of x, and the variance of the constant b, you follow this, you are getting 0. So this thing you have to jot down. Okay, it's the same. This formula is applicable for discrete random variable in also continuous random variable, right? So just by knowing all the expectation of x, the mean, the ex square, the variance, you can find other value that the question requested, right? For example, alright, so if the question is asking us to evaluate the expectation of 3x plus 2, alright, there is two methods. Alright, one is you integrate everything here by multiply this function into the integral that just now I tell you. Alright, but that one is a bit tedious and not a smart way, because why you're going to integrate, okay, then the chance of doing the careless mistake is higher, right? So now very simple, apply these properties, right? These properties here. So 3 is like a, right? It's a constant. So 3 ex plus with expectation of 2, right? You are getting 2. So very simple, right? Very simple, okay? Just use the value that you found plus 2, right? So you have 6 plus 2. The expectation for this will be 8. Alright? Very simple. So let's say if the question asking you to find the expectation of 2x2 minus with 2x plus 1, also very simple, right? So if you want to using the integration method, it will be very tired, okay? So just apply the properties here. So it's even though there is no x power of 2 here, but it's still the same. You can just take out the 2 expectation of x squared minus with 5, right? Minus negative 5 expectation of x. So expectation of constant, this is 1, so you were getting 1, right? Then you just plug in all the value that you find just now. 29 over 6 minus with 5 expectation of x is 2 plus 1. Then after evaluate, then you are getting your expected value for this function, okay? Which is 2 over 3, alright? Which we're giving you the value of 2 over 3. So hope you can understand, right? So now I'm going to teach you how, right? Okay, so if the question is asking us to find the variance, right? The variance of 2 minus with 5x, right? We can evaluate the variance by using the properties here, alright? You can just writing this way, okay? Variance of 2, right? Variance of 2 plus with variance of negative 5, negative 5, right? Negative 5x, right? So later on, if the variance of 2, right, variance of a constant, it will be 0, alright? You are getting a 0 here, and plus with, and don't forget that you have to power of 2, right? This one. So you see that, and the value here, right? The value with x, you have to be power of 2. So means that negative 5 power of 2 multiplied with variance of x. So at last you just take the value of 25 multiplied with the variance of x that you found just now, which is 5 over 6, which is 125 divided by 6. Okay, very simple. So you just using the properties given, okay? It's the same, right? It's the same for this, it's the same for discrete random variable and continuous random variable. You can refer back to the discrete random variable for more detail, alright? So now I have already tell you the properties. I have revised the properties, and how to using all these properties is evaluate the mean, the variance of a different function, alright? So by this is the most important is you must know how to find the expected value of x by using the concept of integration of by using the probability density function, by multiply the function x into the function, alright, during your integration, right? I think that's all